Hi, today we're going to talk about weight percent, and weight percent is related to our first course goal because it is a concentration unit. So weight percent is often abbreviated as WT percent, and it is defined as grams of solute for every 100 grams of solution. You may see it abbreviated another way. You may see it simply as percent with parentheses W/W, where the W stand for weights, right? Because we have a unit of weight in the numerator and a unit of weight in the denominator. You may also see it simply as percent by weight. So let's see if we can do an example. Let's imagine that we have a solution whose concentration is 37 weight percent HCl, and we're given the density of the solution as 1.18 grams per milliliter, and we're also given the formula weight of HCl as 36.46 grams per mole. So using all of that information, can we convert weight percent into molarity? So I might want to begin by reminding myself the definition of molarity, which is moles of solute. In this case, that would be moles of HCl for every liter of solution. And I often don't know where to begin, but I'm tempted to rewrite the definition of weight percent the way that we've written it here. So I might say 37 grams of HCl for every 100 grams of solution. That's the definition of weight percent. And now I can see that I've got to convert this numerator into moles. I think I can do that. And I've got to convert this denominator into volume, and I think I can do that too. I'm going to begin by converting the numerator into moles, and that's where I'm going to use this formula weight. So my first step is going to be to say that for every 36.46 grams of HCl, there is 1 mole of HCl. So yes, we have our numerator finished, and now we've got to convert grams of solution into liters of solution, and that can be done easily using the density. So we can say that for every 1.18 grams of solution, there is 1 milliliter of solution. And then one, I think, trivial step would be to say that for every 1,000 milliliters of our solution, there is 1 liter of solution, and we've done it. We've converted mass into volume using density, so let me cancel out milliliters. And I'm going to do this arithmetic on my calculator. I hope you do too as well. 37 divided by 100 divided by 36.46 times 1.18 times 1,000. I am getting 11.97 something, but I want to remember to follow the rules for Sig Figs correctly. So here in this 37, we have 2 Sig Figs. This 100 won't ever limit us because it's exact. The same for this 1, it's exact. It won't ever limit you. But we have 4 Sig Figs in our formula weight and 3 Sig Figs in our density. So it looks like we're going to have 2 Sig Figs in our answer. So that would be 12 moles of HCl for every liter of solution, or 12 molar. We've solved the problem, but I do want to point out a common mistake I've seen students make before. Sometimes students interpret this density incorrectly, and they say, oh, that 1.18 means we have 1.18 grams of HCl, for every 1 milliliter of solution, and that is incorrect. Don't ever make that mistake. Density is grams of solution for every volume of solution. So I hope you enjoyed this first example of converting weight percent into molarity. We'll do one more example, but I'll save that for a different video. Thanks for listening.